I'm a lecturer at the Q-Step Centre at the University of Exeter, but today I'm actually just going to talk to you a little bit about some of the work that I was doing in between working for my PhD and then moving back into academia. So I had 3 years where I was working in the private sector for an IT analytics company, which was a really useful experience, and I hope to just share some of that with you today. I hope it doesn't sound too egotistical. I'll just sort of like describe some of the features of the job and why the social sciences were quite useful to what I could contribute in that company. So yeah, to give you a bit of an idea of my personal background, originally I did my undergraduate degree in management at the University of St Andrews. I think one of the things that helped quite a lot in terms of then going to work for this IT analytics company who were called Sumerian was that I'd worked for the Royal Bank of Scotland as a project analyst, and then after that I did an MSc in applied social research, which sort of started to whet my appetite for an interest in quantitative methods more. And then I went on to go and do my PhD in sociology, again at the University of Stirling. And my area of interest is very much in educational attainment and understanding the influence of different family background variables on that. So I developed quite a lot of experience of working with multivariate models and different types of modelling, which turned out to be immensely useful in this job. I think one of the key aspects to, in my particular case, doing a PhD in the social sciences is that I'd undertaken quite a lot of training in quantitative data analysis. Lots and lots of thinking through the process of assumptions, the kinds of model fitting, a lot of the technical aspects of trying to ask good questions. And I've thought an awful lot in that about problems of missing data, problems of measurement, and I think that turned out to be really pretty handy in a business context. So the company I was working for between 2011 and 2014 are a relatively small company called Sumerian, who work in the field of IT analytics. I'd characterise their kind of journey as flitting between a consultancy where they were going to, in particular, big banks and quite large companies and offering to analyse their data to answer questions, but they were always trying to move towards their kind of current product offering, which was to do with looking at issues such as capacity planning across a whole service suite. I think the concept of exhaust data is immensely useful in this particular area because a lot of the work they were doing was looking at IT, or the logs compiled by various pieces of IT equipment, so servers and machines, being able to extract that information into a format where it could be analysed. That's the sort of area that we would refer to commonly as data management, and then from that reformatting it into the kind of data that then can be analysed and therefore presented back, so that the customers of Sumerian were always trying to ask them, or always had the kinds of questions that they just didn't have visibility of because of the nasty format in which that data was recorded originally. So as a data scientist at Sumerian, what did my job really entail? Well, really, a lot of it was asking questions about system performance, so trying to understand where the bottlenecks are across a whole farm of servers. A lot of it was to do with moving towards cloud computing and trying to understand, okay, what's the typical behaviour of, say, this lump of old hardware that we've got here? What would this look like if we chucked it onto a brand new machine in the cloud? You know, how many virtual machines are we going to need to sort of like equivalent the workload of this? So a lot of their interest was in trying to understand the behaviour and performance of these machines. This term latency, you may not have come across, that's to do with like foreign exchange transactions, and so going down to sometimes fractions of milliseconds to understand when you have transactions to buy and sell foreign currencies coming across the Atlantic. You are trying to understand and decompose where you can speed up these things. And a lot of this, that's where my kind of background in terms of multivariate modelling really started to be useful. In terms of practical skills, I'd say this second point up here, so I was involved a bit in terms of reviewing and parsing the raw data, so I'd just get a kind of data source thrown at me. Eventually what was happening is that the company was sort of building up a schema of the different formats of these exhaust files and where to rip out the bits of information they want. From that, there was just like a bit of a pipeline that developed where this would then get published into multiple database schema so that you've got it in a nice grid format, which looks like the kind of stuff that social scientists would be used to working with, but perhaps not in a sort of like fragmented star schema where the data are all compiled into different silos where you have to then join it back together. So that it was a bit of give and take. I learned a lot about that kind of aspect, but I didn't do that alone. I worked with a whole team of people. I think the bit I brought to the party was really about the statistical modelling and also the communication side of that. So the visualization side of that. I think that was something in terms of social science background that you're used to trying to present complex ideas through multivariate models and then try and express them relatively simply in a way that a customer might be able to understand. And then moving towards when this company Sumerian were trying to develop software a bit more, then I got involved a bit more in the sort of development of some algorithms, a bit of the automation of the analysis, and really trying to define some of the requirements of software design to look at moving old networks of servers into the cloud. So I would characterise the sort of challenges faced by our clients as really being about using actually quite old technology. So a lot of these IT legacy systems are pretty old. A lot of the managers and IT administrators don't have an overview of their IT systems in an easy way. They have it at the exact moment that a server is operating, but they didn't have access accessibly to the kind of log files that they're working with. And they didn't really have the capacity to do much more than beyond their day job in terms of managing these estates. The second point I've already made, you can just configure a server to keep records, essentially. That's firmly fitting within this exhaust data pattern. And really, the bit I suppose Sumerian was helping with was actually stripping the irrelevant information out of those log files, getting them into an appropriate format, and then actually working with the kinds of performance metrics that make you understand that server's behaviour. So I don't want to claim that I did this by myself by any stretch of the imagination. I think it's important to note that I worked with a bunch of really, really talented people. I'd say, if I was to simplify it, it would be this. The computer scientists at this company were really good at setting up this information pipeline to really get this information in the right format to use it, particularly that kind of scale of data. The web developers are really, really good at writing the kind of, the scripts to produce the visualizations, to make them very interactive. Actually, the interesting side of things is if you were to focus in on the social science bit, a lot of the other analytical employees in this company had a business information background, so they're used to reporting and standardized ways of pushing out information. So they have some IT domain knowledge, but really limited on the stats training. And that's where I think I stepped in a bit more. So they understood a bit about correlation, and they understood a bit about distribution, but they didn't really understand some of the sort of processes going on, thinking, well, hang on a minute, you're compiling this data, what does this server really do? Not trying to make it more than just a simple association between two variables, and actually starting to understand the process. And I think Susan referred to that a bit in terms of some of the skill set that comes with the social science background. So yeah, I'd say I brought a bit of experience of multivariate stats, a bit of challenges of error and estimation. I was quite used to writing code using the statistical software Stata to begin with, to kind of implement these routines. But whilst you're there, you find this is actually quite transferable quickly. So I started to get into regular expressions, which are about pulling the information out of these log files. Then I developed a bit of the knowledge of SQL, so structured query language, MDX, the statistical package R, a bit on this last bit at the end, DDLs, is all about how to then present that information. So actually, what would happen is that I would sort of say, well, I've got a rough idea of what I think this should look like, and then I'd go to someone else in the team who would also help me work with that. But I sort of think I've mostly brought the kind of stats background to this. So, if I was to give you just some brief examples of the kind of work I was doing, yeah, we did some work, as I sort of hinted at earlier, looking at foreign exchange requests, and I used some regression modeling to try and understand the sort of reasons for why some of these transactions were quicker and slower than others. In fact, just as a bit of an aside, I helped them understand a term called multicollinearity, so that if things are happening simultaneously, you can't really distinguish some of these effects. You've got to understand the process that actually drives how the machines work. I also did some work for a retail bank using logistic regression modeling and survival analysis around customer complaints. So how long they had a customer complaint on their system, and then trying to understand variations, not just by geographical area or types of customer, but also try to understand which of these factors mattered more or less once you could do some kind of statistical control. I also looked a lot at sort of understanding the performance of, if we were to take a set of servers, move them into a virtual environment, how they would collectively perform, and I did some work using polynomial fitting and sort of matrix transformation just to understand across 24-hour periods what the kinds of patterns of behavior would look like when you combined servers into that environment. But also, I think sometimes it just boiled that back to real basics, trying to understand, a covariance structure. A lot of the kind of statistics that was being used in the company would just model things as if they were completely independent processes from one another. Understanding the covariance structure was just trying to turn around and say, actually, this server is not busy when this server is busy. You can actually combine their workload, and actually you don't run too much risk of this machine running hot. And as you can imagine, that saves people potentially a pile of money. So I'll stop there. I'm very happy to answer any questions, probably best at the end. But I would say in summary that actually the social science kind of background that I had coming into this type of work actually worked very well, because I tended to think about the sorts of things that perhaps a lot of the other analysts and computer scientists didn't tend to think about. Thank you. Thank you.